Okay, so this question here is a bit more in depth. The question states the bearing of B from A is 060 degrees. So the bearing of point B, okay, point B from point A, so the bearing of this line here is 060 degrees. In other words, the angle from the North Pole to this line here is 60 degrees. The next part of the question is it states angle ABC is 45 degrees. Now when they write angle ABC, what they are talking about, they're not talking about the angles of each one of these points A, B and C. They're talking about the angle at the point of the letter in the middle. In this case here it's B. So the angle at point B. This one here being point B. If they wanted to talk about the angle at point C, then they could put ACB. It's always the letter in the middle is the angle that they're talking about. So in this case here, it's B. Angle ABC is 45 degrees. So this angle here is 45 degrees. And the next part, triangle ABC. Now they use the phrase triangle ABC. If this diagram here had two different triangles on, and this one is ABC and the next one would be DEF, let's say, triangle ABC is indicating they are talking about this triangle here and not the other one. If there was another triangle with labeled DEF, then it would be called triangle DEF. The triangle ABC, this one here, is an isosceles triangle. Isosceles, from the Greek meaning equal leg, means two of the sides are the same, which also means two of the angles are the same. In our case here, this length here and this length here are the same, which means this angle here is the same as this angle here. Now they want us to work out the bearing of A from C. So the bearing from point C here to point A there. So the bearing of this line going in this direction. Okay, that's what they're asking us. So the first thing I would look at is this word here, isosceles. Isosceles, as we described before, means these two lengths here in this particular case are the same, which means that angle there and that angle there are going to be the same. One key point we need to remember is the angles in a triangle always add up, and that's the internal angles. This one, and this one added together make up 180 degrees. Now we can see here we've got a triangle, we've got two angles missing, but they're giving us one. This one here, 45 degrees. What we can do is take our 180 degrees and take away what we know. Take away the 45 degrees, giving us a remainder of 135 degrees. So these two angles here added together, or the sum of these two angles, will equal 135 degrees. Because this is an isosceles triangle, these two angles are the same. So we can take our 135 degrees, divide it by 2, and that will give us the size of each of these two angles here. So 135 divided by 2, 67.5 degrees, 67.5 degrees. So the angle at point A is 67.5 degrees. Oops. And angle at point C is also 67.5 degrees. Okay, so we've managed to figure out the size of these angles, the internal angles of this triangle, and a quick and easy way to check is if we add them all up together, it comes to 180 degrees. So we know we've got that bit right. Now we can look at this part of the question here. The bearing of B from A is 060. So the bearing of this point here from this point here, so the bearing of this line is 060, or in other words, the angle from north to that line going out to B is 60 degrees. With this information, we can now figure out what the bearing of C from A is. We haven't quite got to answering our question, but we can figure out the bearing from point A to point C. We can just combine the angle or bearing to point B, to our 60 degrees, with our angle from this line here going down to the line towards C. If we combine those two, that will tell us what this big angle here is, or the bearing from point A to point C is. So we can take our 60 degrees from this part here, and we can add our 67.5 degrees that we worked out here, add them both together, and that gives us 127.5 degrees, or the bearing from point A to point C is 127.5 degrees. But our question states work out the bearing of A from C, so it wants to know the bearing from point C going to point A in this direction. So we have it coming down this way, 127.5, but we need it going back the other way. In other words, we need the back bearing of what we just worked out. Now remember, bearings are always done in a clockwise direction, okay? And we've worked out the bearing from A to C. We need to come back again. The simple way to do that is to take our 127.5 degrees, and we want to come back in this direction. So we need to take our angle from here all the way around and take away what we already know. So to do our back bearing, we do 127.5 degrees, which is coming down this way, and then we want to do a 180 degree turn, go right back the way we came. So we are just going to add 180 degrees, giving us 307.5 degrees, or the bearing of A from C equals 307.5 degrees. So this bearing going up this direction here, you would have to follow a bearing on your compass of 307.5 degrees.